So next topic is first law of thermodynamics. This is a basic law of conservation of energy. Consider this system of an ideal gas having a piston and we have our gas particles. Okay. Now let us say that dq is small amount of heat supplied to the system by surrounding, to system by surrounding. Okay, let us say dw be small work done by the system on surrounding. Okay, we have small heat provided to the system by the surrounding. We have small dw, which is small work done by the system, because the heat supplied to the system, that will increase what? That is going to increase the intermolecular forces of repulsion attraction, because the translational energy is going to increase and hence they are going to push this piston away. That means they are performing some sort of work. So this is what I have written. dw is the small amount of work done by the system on the surrounding. And let us say du, because we have just studied about internal energy, that internal energy will also change, because internal energy is a state variable. It is going to change with change in temperature, pressure, etc. So du is also, let's du be the small internal energy, small change in internal energy due to supply of this small amount of heat. So first law of thermodynamics states that this dq is equal to du plus dw. This is the basic law of conservation of energy. It states that small amount of heat given to a system is used partially in increasing or in changing. I won't say increasing or decreasing, because if dq is negative, that means if you are taking out heat from the system, the internal energy is going to decrease, so work will be done on the system. So we are going to talk about the sign conventions in a while, but we are not going to increase, we are not going to use the word increase or decrease, we are going to just use the word change. So small heat provided or small change in heat provided to the system changes the as part of it changes the internal energy of the system, and rest part is used in performing work by the system on the surrounding. This is the first law of thermodynamics, and that is why we relate it to the basic law of conservation of energy.